Okay, so I would like to remind to all the presenter, okay, you will give 50 minutes for your presentation and also another 5 minutes for the Q&A. All right, so for the Q&A, I already make you available to present, okay, to share your screen, everything. So if you have any problem, you can say to me. So next, I would like to say thanks to all the examiner for joining this session. So we have Dr. Fatima and Dr. Rohila, and also, okay, these two person first. All right, so I think we can start now. Are you ready, Sumik?
Yes. Good afternoon, respected examiners, supervisor, and FIP2 coordinator. My name is SOUMIK Bhattacharjee, and today I'm going to present on my FIP2 final presentation, the topic of which is Design and Finite Element Modeling of Multi-Channel QCM for Odor Characterization of Volatile Organic Compounds. In this presentation, I'm firstly going to give an introduction to the topic. Then I'm going to explain the theoretical studies behind this project. After that, I will be explaining a literature review that I've conducted for the project. After that, I'll explain the research methodology that has been followed in this project, the design of the sensors and the sensor with the sensing film. And lastly, I will be listing down the objectives that has been achieved from this project. So firstly, VOC or volatile organic compounds. These are basically hydrocarbon chains containing benzene, toluene, and formaldehyde groups, which are considered carcinogenic and have health issues and environmental hazards. WHO has declared a limit of 130 parts per million concentrations of VOC to be emitted from different sources. And due to its environmental hazards, it needs to be monitored and detected. This project aims to design a multi-channel QCM sensor for the detection of VOC concentrations, and each of these sensors will have different number of channels to identify the optimal design for the sensor. And lastly, a QCM sensor will be designed with a sensing film to detect VOCs. So the problem statement behind this project is that firstly, VOCs emitted from industries and households, they contribute major effects in environmental terms and also in health terms. So conventional QCM sensors or quartz crystal microbalance sensors, usually they have one or a single electrode fabricated on top of a single wafer, which decreases the area for detection of the VOCs. And again, traditional gas sensing methods such as gas chromatography and NMR are costly and they are time consuming. The objectives of this project is to design and simulate a QCM sensor using finite element modeling and using the COMSOL multiphysics software. It is to compare and investigate the performance of each of the sensors which have dual, triple, and quad channels for the purpose of VOC detection. And lastly, it is to design a QCM sensor with an optimal sensing film for VOC detection. The scope of this study includes modeling the sensor using finite element modeling and to set the optimal parameters to design the sensor, to simulate and analyze the performance of each of the sensors and compare them, and to develop a QCM sensor with high mass sensitivity. Thus, the hypothesis of this study can be declared as the MQCMs will have an optimal frequency of 10 megahertz with a quartz thickness of 168 micrometers. The QCM sensor will gain a mass sensitivity of 20 hertz per nanogram with a shift in resonant frequency of 4 to 30 hertz. So the theoretical studies behind the project is that a QCM sensor or a quartz crystal microbalance sensor is built with a quartz crystal wafer. Now, quartz is a piezoelectric material, which means that whenever it undergoes oscillation, it produces electrical properties. So when an AC current is passed through the electrodes of a quartz crystal, it shows a change in the resonant frequency of the acoustic wave. Now, this change in the resonant frequency can be calculated in order to calculate the change in mass, and hence calculating the mass sensitivity of the device. A literature review has been conducted in order to list down the recent publications related to multi-electrode QCM. This list is divided according to these type of sensing material which is used for the device, and the sensitivities obtained from these experimental studies range from 20 Hz per parts per million to 70 Hz per parts per million. The project methodology that has been followed in this study is firstly designing the MQCM sensors with a different number of channels, then to set the electrode radius and the quartz thickness of each of the sensors. After that, it is to vary the C2C distance and analyze the performance of each of the sensors depending on the C2C distance which is set. And then it is all the performance of each of the sensors are compared, and the optimal resonant frequency is selected. Lastly, a QCM sensor is to be designed with an optimal sensing film. So the goal of this project is to obtain highest resonant frequency in order to obtain a high mass sensitivity. Now, before we go to the design of this MQCM sensor, we need to understand the frequency domain analysis that has been conducted. QCM sensors conventionally they come in a resonant frequency of 1 to 10 megahertz. Industrially, they are available in 3 megahertz, 5 megahertz, and 10 megahertz. Now, this study has been conducted so that we can understand the relation between resonant frequency and quartz thickness. So as you can see over here that with the decrease in quartz thickness, the resonant frequency of the device increases, which in turn gives a high mass sensitivity. So here we will be choosing a lower quartz thickness in order to obtain a high resonant frequency. 168 micrometers of quartz thickness obtains a resonant frequency of about 9.86 megahertz. And the same study is conducted with the help of COMSOL for the finite element analysis. In this graph, you can see we have obtained three distinct frequencies of 3.4, 4.95, and 9.85 megahertz. It is clear that 9.85 megahertz obtains a high sensitivity over here. So the parameters for the design of the sensors, first of all, the parameters are chosen within the COMSOL software. As we have seen already, the quartz thickness is chosen at 168 micrometers. Accordingly, all the other parameters are also chosen. And then I have used the geometrical shapes which are available within the software to design the sensor and each of the channels. The materials used over here are quartz and gold. Electrostatic properties are also fed into the design for the terminal and ground. And a mesh component is added to the design in order to find out multiple points on the surface of the sensor so that we can select the points and obtain a point graph showing the displacement versus resonant frequency. Now, as I said that MQCMs, they have multiple channels on top of the same quartz wafer. So it is seen that the distance between each of the channels affect the resonant frequency of the device. So it is seen that the closer the channels are, there's more interference or noise in the resonant frequency. So over here you can see that these two graphs compare the C2C distance. When in the case of 7 millimeter of C2C distance, the resonant frequency graph is obtained very clear, and all of the points are equal to 9.58 megahertz. Whereas when the C2C distance is kept as 6 millimeters, the resonant frequency shows a lot of interference or noise, and the resonant frequency is not obtained equally, or they don't fall on a concurrent line. And hence, in this case, 7 millimeter will be chosen over 6 millimeter in order to minimize the interchannel interference. Hence, we will be designing each of the sensors with a different C2C distances so that we can understand which is the optimal parameter to obtain a high resonant frequency with low interference. The distances chosen are 7, 6, 5, and 4 millimeters, and the summary of it are given over here. In the case of two channels, a C2C distance of 5 millimeter gives the least interference of with a resonant frequency of 9.58. Similarly, in three channels, 7 millimeter C2C distance gives the least interference. In the case of four channel, 5 millimeter gives the least interference. Over here, you can see the graph that even though 6 millimeter of C2C distance gives a high frequency, but it doesn't give the least interference, the least interchannel interference, and hence the C2C distance varies between each sensor. However, all of these sensors exhibit a resonant frequency of 9.58. So based on that, a QSIM sensor with a sensing film is designed. Now, in order to design a QSIM sensor with a sensing film, we have to identify what gas we are sensing as the gas analyte, and also what sensing film we are using. Now, in this project, acetone is chosen as the target gas due to its various applications in gas sensing. And for that, chitosan chitosan film is used as the sensing film. Now, chitosan is a linear polysaccharide or a chain of glucoamines, which is obtained from shells of aquatic animals such as seashells and lobsters. The literature review that has been conducted for this project shows that chitosan films are used widely for gas sensing, mainly for acetone vapors, and that is the reason why chitosan is used. So the parameters which are mainly concerned over here are the concentration of the acetone, the goal radius, and the molar mass of the gas, which is acetone over here. Now the concentration will be varying to study the performance of the sensor depending on the concentration change. So it has been divided into three concentration ranges. One is baseline, where the concentration is 0, then 10 to 100 parts per million of concentration, and 100 to 1000 parts per million of concentration. So the baseline study is considered as a control study over here in order to understand and study if the QCM sensor designed is capable of detecting any kind of change in resonant frequency, eventually any kind of change in mass. So over here, acetone concentration is kept 0, even though the molar mass of acetone is present. So this control study helps us to understand if the QCM sensor is capable of detecting any kind of change in mass. So if that succeeds, then we continue to the other two studies. The frequency range over here is chosen as 9.55 to 9.58. It is kept as a very narrow range in order to obtain precise values. The higher limit of this frequency range is chosen as 9.58, which we have obtained from the MQCM sensor study. And the change in mass is derived from Sorbury's equation, which is given as follows. So if we find the change in frequency, then we can easily find the change in mass. From the study, we have obtained this chart in which we can see different concentrations give different change in frequency, accordingly change in mass. And the QSIM sensor with the chitosan sensing film obtains a mass sensitivity of 17.389 hertz centimeter square per nanogram, which is quite close to the hypothesis that we had determined in the beginning of 20 hertz per nanogram. The graph on the right shows the linear trend between the change in resonant frequency and change in mass, which satisfies Sorbury's theory. The R-square value, which is the coefficient of determination, is obtained as 94.31%, which means that if the study is conducted again with the same set of values, it will have a chance of 94.31% to obtain the same results. Similarly, the concentration versus change in frequency is also studied. I have divided it into two sets, one with the 10 to 100 ppm and the other with 100 to 1000 ppm to calculate the coefficient of determination. In the case of 10 to 100, the determination value is obtained as 95.64%, and in the case of 100 to 1000, it is obtained as 98.77%. So that concludes the study, and all the objectives listed out in the beginning has been achieved from this study. Now, in conclusion, the mass sensitivity of the sensor is achieved at a quite considerable value, and the coefficient of determination is at 95.64% for 0 to 100 ppm concentration of acetone. And this chirosan-based sensor can be used to detect acetone, and it has applications as a breath analyzer for detecting the levels of acetone in diabetes patients. The plans to publish this study of FIP2 is to publish it in Indonesian Journal of Electrical Engineering and Computer Science, and it has already been accepted for 9th International Conference on Sensors, Asia Sense 2021. It will be presented at the conference as well. So that concludes my presentation, and thank you very much. Good afternoon.
Okay, thank you, SOUMIK. All right, so now we open for Q&A. Dr. Rohila.
Good afternoon, everyone. Thank you, Soumik.
Thank you very much.
Soumik, you are doing on the detection of VOC, right?
Yeah. Yes.
You design the QCM. Can you go to your objective?
Yeah, sure. I'll share my screen. Yes, can you see my screen?
I don't see black. Okay, now.
Okay. So my first was using the console, and then to design multi-channel QCMs with different number of channels.
Can you point to the
and then
objective slide? I couldn't see. Okay. So the first objective to design and simulate QCM array using the software, right? COMC.
Yeah.
That one.
Yeah.
Okay. Secondly, to compare and investigate the performance of different QCM. Here, what is your performance measurement? Yeah?
The performance is the resonant frequency, depending on the number of channels.
Resonant frequency, some more?
So since multi-channel QCM have different number of channels, like different channels for the sensor, so I have chosen 2, 3, and 4, and then I'm comparing each of the sensor performance. Performance means the resonant frequency and how is it high or not, and what is the C2 distance.
That is your design. Now I'm asking about the performance measurement. You said just now is about resonant frequency, which means you will measure the resonant frequency for all the design that you implement, right?
Yes.
Okay. The other one, do you have any other parameter to measure your performance? Because I noticed you said something about the interference.
I have a parameter called
for the interference.
Yes, the interference. Yes.
So how do you
Yeah,
measure
that is another parameter. I vary the C2C distance. So C2C distance is the distance between the center of each of the channels. So I have to vary that in order to understand. I have to. That's affecting the interference. So I have to study that. That is another parameter.
Sorry, how do you measure the interference in terms of what? The frequency or how?
Yes, in terms of the frequency. In terms of the frequency. So so there are four distances: 7, 6, 4, and 5, and 5 and 4. So I see the resonant frequency for each of the distance, and then I see if there's interference showing.
How do you know that there's interference in the resonant frequency?
I'll share that. Okay.
Can you show?
Here, yeah, yes. Can you see the screen? The interchannel frequency interference.
Okay.
Yeah. So this graph is giving for 7 millimeter, right? This graph is giving like 9.58 megahertz for all the channels, but this one,
Which means red, green, that one is for the channel because you didn't insert any legend here, so I don't know what the
oh,
color represent.
oh, okay, sorry, miss. Yeah, so each of the color is for each of the channels. So red is maybe this one, and then green is this one, and the blue is this one.
I show me. Okay, and then which one is the interference? Because in the graph here, you only show me the resonance frequency. Now I want to check what is the interference. For example, I want to know what
The interference is judged if the resonant frequency is coming equal in 3 of the channels or not. Here they are not coming on a concurrent line, which means there's a difference between each of the resonant frequency.
Hold on.
So that's how I judge that there's interference. It's actually from previous studies. They have also
why you have to compare all the 3 channels? I mean, from my understanding, what you said just now, you plot the apa tu the channels frequency, the fundamental the resonant frequency for all the channels, and then you would check which one is the resonant. If let's say it's occur at the same time, then that means no interference. You means like that?
Yeah.
Yeah. Are you sure?
Because from
If let's say
literature
I'm
review that I've done.
Samir, if let's say I only have one channel, so how do I know that that one has interference or not?
One channel wouldn't have interference because there's no interference is for inter-channel, which means if there's 2 channels, then only there can be interference.
Must compare between more than one lah. Okay.
Yeah.
Okay.
Sorry, miss, for making it difficult. Sorry, miss, for making it difficult.
All right. One more thing is about mass sensitivity. I noticed that you have mentioned about the mass sensitivity. I think that is another performance measurement that you apply in your study. But I didn't see any result for that one.
It is here. This is the mass sensitivity result.
Oh, on the chitosan, this one, on the detection of the VSC here.
Yes.
Okay. Okay.
It is based on the Sorbury's equation. So there's a formula for it, and then we can find it if it's high or not compared to other studies.
Okay. Can you go back to your objective just now? The second or the third, or to design, which one? Hold on. This one, the last one, to study the surface chemistry of the electrodes and design using the optimal sensing. What does it mean, that one?
Here I mean actually to select a sensing film. So I'm selecting chitosan as my sensing film for acetone. So that's the objective, to find to design the QCM sensor with a sensing film so that we can detect acetone. That's the objective.
This replace to study is not correct. I mean the verb not to study, to analyze perhaps. You may change to analyze. Yeah.
Okay. Yeah.
Hold on. In your thesis, you have mentioned about finite element method. Here you didn't include, yeah?
So COMSOL is a software which uses they use finite element modeling, and also
what is that? Element analysis. What is that?
So it's basically what I have the knowledge for is that it's simulating, and it's a parametric study. So it means that you have a in your parametric table, you have set your parameters, but then you can do a parametric study in order to vary that from in a range.
So
So
this
it's basically
table is your,
simulating and sorry.
so this is the table for FEA. Are you
Uh,
sure?
this one.
This one. Do you
This is
perform
the
any parametric study in your
yeah
project here? Which one? This one. This
yeah.
table.
Yeah, in the software we have a section called parametric sweep where you do the parametric study.
But
So
you not look into all the parameter, right? You
no,
only
yes,
there's certain parameter only, right? The rest you
certain
fix.
parameters only. We are keeping the radius constant, the quartz thickness constant, because we want to keep the range of the frequency at 10 megahertz only. We don't want other megahertz to come in, other frequencies to come in. So that's why we are keeping some of the parameters constant.
Okay, last question. About
Okay.
displacement. I don't know now what meant by the displacement here in your results, because in methodology you didn't mention anything about displacement.
Oh, displacement. So as I said that the quartz
The
crystal microvalence.
y-axis, your
Sorry.
y-axis in your graph. Just now,
Um,
the
this
graph.
one is
That one. Because I
uh,
noticed in your thesis all the you put as displacement, not
yeah.
not the what they call. I forgot already. What that does it mean?
So as I said that QCM sensor, when they oscillate, they have electrical properties. Oscillating means that they have a they show displacement in within their cross section.
What?
So the higher,
Come again?
sorry.
Come again? Sorry.
So over here, when I'm explaining that what is a QCM, over here
Uh,
when an AC current is fed into the quartz crystal, they show displacement or oscillation within their cross section. So this software helps me to see how much of displacement is causing and how much of the resonant frequency is changing. So that is the displacement over here. This displacement means the displacement in the quartz crystal, in the cross section of the quartz crystal. So the displacement, it is not a factor over here, but then we consider it like maybe with high mass sensitivity the displacement is higher, but we are not studying that over here. So this quartz crystal is been it's detecting the resonant frequency. That's what it is.
okay.
Uh, is it clear? Sorry.
Not really, but see lah how it's okay lah.
So the displacement is basically the oscillation in the, I mean, it moves the
What is the measurement there?
across the thickness of the.
I couldn't see the units. What
The
the
measurement
what
we are
is the
not
unit?
actually looking at the displacement measure over in this study.
You can get it to me. It's okay that I'll go through your thesis here. Displacement field. Right, in meter. Okay, I think overall okay. Your literature review well explained. No problem on your literature review. Only on the because I will check on your objective whether you achieve or not based on your
Yeah.
results here.
Yeah.
Okay lah then. Yes. Okay. See lah your report later.
Okay, Miss.
Yeah. Okay. Okay, Dr. Anwar.
All right, thank you very much.
Thank
Okay,
you,
so
Miss.
Vix, please take note all the advices, okay, and also all the correction you need to do after this. All right, so next we move to second candidate, is John
Yeah.
RAKSHYS. Okay, John RAKSHYS, are you ready?
Yes, sir.
Good day to everyone present in this meeting. My name is John RAKSHYS, and today I'll be presenting my system called Automated Streetlight Control System based on a microcontroller. So let's take a look at some of the topics I'll be running through in the presentation today. Now, starting with the abstract, the introduction, literature review, research methodology, results, and conclusion. So looking at the abstract, I've divided it into four sections. One is the purpose, and the purpose of this project is to save electricity that is being used by streetlights, and in turn improve their efficiency and also their bulb life, the life of the bulbs that are being used in the streetlights, and also to support automation in daily life as we're moving towards a more automated world. So the design for the system is that it has an LDR detector, or light dependent resistor detector, that senses the ambient light conditions. We have an IR sensor that is present to detect the vehicles that are passing by. We have an AT89S52 microcontroller as the main controller, and we have an optimized algorithm, and we're using pulse width modulation to reduce the power consumption. So what I found after implementing the system is that there is a 28.57% reduction in power usage, 15.38% reduction in electricity usage, and 0.19% reduction in voltage that's being used. And also there's an extra optimized algorithm that I've developed that will lead to increased bulb life. And the value of this project, or what it can bring to the society, is that it can be implemented in a smart city to aid automation, and it also contributes to reducing our carbon footprint. So the problem statement for this project is that there are conventional lighting systems, and most of them still use high pressure sodium lamps rather than LEDs, and there's about 22,964 terawatt per hour of electricity being used worldwide. And also most countries and cities do not have an automated streetlight system to control the brightness. So a bit about the project, as the name suggests, it's an integrated light system that can be directly fitted to a lamp, and its main function is to reduce the brightness of a vehicle upon the detection, brightness of the light based on detection of vehicle and also the ambient light, and its result or aim in the end is to save electricity and improve efficiency. So let's take a look at some of the objectives that I've set for myself in this project, and they are to study and evaluate the requirements and techniques to develop an automated streetlight control system based on a microcontroller, to model a system that can show a reduction in power consumption upon implementation, and to measure and perform testing to ensure that the system can light up the path of the vehicle correctly without any lag or delay. So the hypothesis, or what I hypothesize for this project, is that if we implement a system with the capability to reduce its brightness level using vehicle detection and ambient light sensing by adding components such as an LDR and a vehicle detection unit, we will reduce power, amperage, and voltage consumption, because pulse width modulation is a method that is used to reduce power delivery, which means the system only uses high power when it needs to, and at all other times stays in its low power mode. So for this system, I've gone through a lot of different papers, but because of a time crunch, I'm only going to be discussing the the drawbacks of the system that were used as my research gap. So as you can see, this system does not use any real-time data. It does not account for any sudden loss of ambient light, let's say cloud cover or rain cloud in the vicinity. And also it uses internet-provided sunrise and sunset times rather than an LDR. And as you can see, this second system uses video analysis, but however, this model needs to be intensely trained even to obtain minimal accuracy. And if you can see in this paper, it does not use a live feed to directly make changes, hence its efficiency and also dependability reduces. And in this paper, I found out that the system that they were using used a HID light, which is known to be less efficient than LED lights. And also the optimization algorithm that they used did not provide a consistent result at all times. And in this last paper, the system's lights were not dimmed at all, and it did not have any component to detect the vehicles. So all of these were taken into consideration when I was making my research gap. So now let's take a look at how I built the system. So there are essentially two phases to the project, the planning phase, which happened in FYP1, and the execution phase, which happened in FYP2. So this is the project flowchart. This left side here kind of depicts most of the items or most of the tasks that were done in FYP1, and here the tasks that are being done in FYP2. Sorry. So let's take a look at the requirements. So we have, as you can see, there's more hardware requirements than software requirements, which makes it a more hardware intensive project. So let's take a look at the hardware first. I've highlighted some of the most important hardware pieces. So we have the AT89S52 microcontroller, which belongs to the 8052 family. Then we have an 8052 USB development board, which was used to transfer the code from the computer to the microcontroller. We have an IR transmitter receiver, an LDR sensor, and a 5mm LDR sensor, and a 12-volt adapter as a power supply. And to program the microcontroller, we used C as the programming language and an IDE called Kyle-Mu Vision IDE. So let's see how I built the hardware system. So as you can see on the left diagram here, it's a circuit block diagram which kind of represents where the individual components of the system were placed on the board. And on the right, we have the circuit schematic diagram, which clearly depicts all of the different components using their circuit symbols. So I used a process called milling. So I'd like to justify why I use the process milling, because milling does not have any harmful chemicals. It's eco-friendly, it's fast and precise. So the PCB was created in this way, or in this flow, where the CNC machine was uploaded with the files that were programmed and that would tell the CNC machine where to drill and where to mill. So then the milling bit was placed on, and the copper clad side of the PCB was milled, and then a drilling bit was interchanged with the milling bit, and the drilling bit kind of punched holes for the DIP components to be placed inside the board. As you can see here, this is the drilled copper plate. Then all of the various DIP components placed in the holes were soldered together, and this picture represents the silk screen side. So this is the PCB. We have the copper clad side and the silk screen side. So let's take a look at the software. So the scenarios I had to consider for making the code is that I had three basic scenarios. Daytime, where if the brightness outside is high, the lights will stay off. Low light condition, when the light is low enough that the light is required, but not required to run at full brightness. This is the second scenario. And the third scenario is in the nighttime, where the lights will stay in minimum brightness until a vehicle is detected, where it's switched on to full brightness. So this is the code algorithm that I've devised for this project. So as you can see, first we have the LDR detecting, and if there's a high amount of light, the pulse width modulation and pulse width and power modulation routines are set to fully off. But if there's a minimum amount of light in the surroundings, then it's set to low brightness, and if a vehicle is detected, it is set to high brightness. And if a vehicle stops in a zone, it's in low brightness, and if a vehicle crosses, it's in high brightness. So this is the optimized operation algorithm for the process. So we have the 4 optimization modes. So 4 LEDs will be turned on at detection point 1 as it's a straight and the detectors are next to each other. 6 LEDs are turned on to full brightness from detection points 2 to 3, and 7 LEDs are turned on from detection points 4 to 7, and all 14 LEDs are in low brightness mode when no vehicle is detected. This helps the system run more efficiently. So the timeline for this project is as such. We have 2 years, and the first year was FYP1, where I did all of these steps, and this FYP2, where I did all of these steps, and all of the corrections are being made simultaneously as I get feedback from my supervisor and coordinator. So let's take a look at the results. So this is the resultant model that was created. So I've labeled all the components here, the AC connector, the microcontroller, the LEDs, the resistors, and etc. So these were the experimental results that I received upon testing my system. So I will explain it in the next slide graphically, but just one thing to keep in mind is that since it's a model, the absolute values are not as important as the percentage differences, as they would be more relevant to a real-life implementation. So as you can see, we can clearly see that when all LEDs are on low brightness. So when there are 7 LEDs on, we are using maximum amount of power. 4 LEDs on, we're using less amount of power, and when all LEDs are in low brightness, we're using minimum amount of power. So the difference between all on minimum and 7 in maximum is 28.57%. We're getting a 28.57% reduction. And in terms of amperage or current, we're getting a reduction of 15.38%. And for voltage, we're getting a 0.19% reduction. So I'd like to conclude by saying that all the objectives for the final year project has been achieved. And on top of that, we were able to show that the system reduces the electricity consumption. It was able to illuminate the vehicle's path safely while maintaining efficiency. And thus we believe that it will play a role in reducing the carbon footprint. So thank you for your time and attention, and let's just take a look at the demo video after this. Good day to everyone. Today I will be presenting my automatic streetlight control system based on a microcontroller demo. So in this demo, we'll be covering the cases listed on top. So let's start with the system overview. As you can see, there's an array of LEDs, which are all of the glowy bits. And between them, we have the IR sensors parallel to each other. We have a power supply, which is connected to a power adapter. We have the microcontroller, the LDR, and a reset button in case something goes wrong with the system. Now let's take a look at case 1, when there's a lot of ambient light in the surrounding, or also known as daytime. So I'm going to use this flashlight to emulate the daytime. So as you can see, when I put the flashlight on the LDR sensor, the lights automatically turn off, detecting that this is a daytime and the lights don't need to be on. And when I take the light out, the lights are back on to their low brightness function. Now for case 2, I'll be using my finger to simulate the vehicle. So as you can see, when the vehicle passes the detection points one by one, the lights ahead of the vehicle are turned to maximum brightness and the lights behind the vehicle are turned to minimum brightness. And when the vehicle leaves the detection zone, the lights are turned down to minimum brightness. In this case, let's consider a car that is stuck at this detection point. So as you can see, the lights next to the car remain on as long as the car is there. And as the car starts moving along and crosses the detection points, the cycle is completed and it goes back to minimum brightness. But it will not be turned on to minimum brightness until the car leaves the zone. And this is what makes the system reliable. Pressing the reset button flashes the microcontroller and gets rid of any errors in the system. Good day to everyone present in this meeting. My name is...
Okay, thank you, John. All right, so now we open for Q&A. Dr. Fatima.
Hello, John. Hi, everyone.
Yeah,
Okay.
good afternoon.
All right. Okay. Can you show me your result just now?
Yeah, sure. Let me share my slide. Sorry, just give me a second. You want me to show you my results section?
Yes.
Okay, which slide would you like to see next?
Okay, the table just now. Okay, so based on your result here, so you compare between the if you have 4, 6, 7 and all LEDs, right?
Yes, miss.
Okay, so that means whether it's on based on the scenario that you are showing just now. Okay, can you go back to your problem statement?
Okay. I think it'll be easier if I just share my screen.
Yeah, I thought I didn't see that just now. Okay, can you just enlighten me on your problem statement, because I have your thesis here.
So yeah, my problem statements are pretty much sorry, 1 second. Yeah, here. So yeah, essentially the basic problem statements for this project were that conventional lights in most countries till date still use high pressure sodium lamps, which are the yellow lights that you normally see on the roads, rather than LEDs, and they are proven and known to be inefficient. And also that there's a huge amount of electricity consumption that's being carried out every day because of the increase in technology that we have around us. And also most of the systems that have been implemented till date do not really have much of an automation to them. They're usually just timer based.
Okay, as I read your thesis, the problem statement, at first you were saying about LEDs versus HID, right? And then as you go through your literature review, everything is about that LED versus HID and how it's not automated. But then when you show your result, you are showing the comparison of how many LEDs, the reduction of power of ampere and whatnot, comparing to how many LEDs. So do you see the flow? Do you see the flow? So at the first you were saying that we should use LED instead of the conventional one, but in the end your result that doesn't prove that LED is better than HID, but instead you just comparing 4 to 6 to 7. So by comparing a number of LEDs, yes, you will have a reduction in what in wattage and whatnot, right? But your project is actually to implement LED rather than HID, right? And then do automation on LED. Maybe that one can be later. Do you understand what I'm saying?
Yeah, the problem with that was I wasn't sure how I would be able to implement HID light or a sodium light, using a model system because
Yeah, I understand that.
yeah.
Yeah, so that's why in your whole project you have to define at the very beginning during your FYP1. So how are you going to measure whether LEDs are better, right? So because it's very confusing when I was reading your thesis. At the first part you were saying different things, and then suddenly your result is this. Is between 4 and 7 and all LEDs. Understand, right?
Yeah, maybe I can include a section that can figuratively prove that LEDs are better, because it's kind of a fact that they are better than HIDs in terms of efficiency. So maybe I could add a section.
Yes, correct. Because the results that you have just now is okay for the second part, using automation, using after having that LED, then when you use that automation, when you use all the sensors and whatnot, you be able to have more reduction compared to if you use LED but still using the same conventional lighting system. Okay.
Okay.
Okay. Hold on. All right. I just went through your abstract. Sorry, your thesis. Okay, the results that you have get in your result section. So you have to put it at the end of your abstract. Okay, because usually when people read your research, they want to know what are you doing, what is the problem, and at the end they want to know what's the result. Okay, so you can include that at the end of your result.
Okay.
Okay, hold on, let me just scroll down your thesis. Oh, okay, one more thing I noticed. I think I've read two theses already, which in the literature review, you put the title of a paper as the subtitle, and then you analyze, and then you summarize the paper. Okay, this is not how you do it. So in chapter 3, so in your literature review, you will have a few subtitle in chapter 3. Let's say what LED versus HID, let's say. Okay, so every paper that you read that have touch on that subtitle, you can cite in that subtitle. It's not like one paper and then one subtitle and then everything on that paper on that subtitle. Understand?
Yeah. Okay.
Okay.
Any more question, Dr. Fatima?
Okay, hold on. I'm scrolling the.
Okay.
Hold on. I've made some comments here. Okay, on the result part, I've already mentioned just now. Okay, I guess that's all lah. Okay, that's all.
Okay, thank
Thank
you,
you,
Dr.
miss.
Fatima and
You're
John.
welcome.
All right, so next we move to another candidates. JUANA, Miriam, are you ready?
Yes, sir. Good day to the panel and to everyone present. I'm Joanna and I'll be presenting my thesis on a real-time traffic light control system based on image processing and object detection. This presentation will cover the introduction, literature review, methodology, results, conclusion, and references. So I'd like to begin by briefly summarizing the essence of this presentation, which is to offer a practical solution to the growing congestion problem by means of a smart real-time traffic light control system. It uses Raspberry Pi and a Pi camera to dynamically control the traffic light LEDs based on the vehicle density and using image processing and object detection techniques. And it noted an accuracy between 97 and 81% in normal to low light. And I believe the value is that it's robust under illumination changes. It could be feasible for practical use. And if it's implemented, it could pave the way towards a smarter city in the future and reduce the various negative effects of congestion. So the problems with congestion are time, fuel, and the mental health of the commuters are impacted. And more importantly, air pollution, more than 1/3 of which is caused by congestion in urban areas. So while it's unfeasible for us to expect to change the road infrastructure, we can instead aim to tackle the inefficiency of the traffic lights, which use pre-programmed time slots and are unable to identify between the congested and the non-congested lanes. Therefore, this thesis proposes a solution, which is a smart traffic light system that utilizes the existing camera setup, works based on real-time road conditions, is able to identify the congestion from the live feed, and uses a dynamic traffic light control strategy to choose the optimal strategy for clearing congestion. So the objectives of this thesis are to design and develop an object detection system, to design and develop a real-time traffic light control system, to perform testing to verify the system's functionality, and to model an improvement over the existing system. So as such, this thesis considers the following research questions, which are determining how the dynamic system could contribute to solving the congestion issue, comparing the queue clearance performance of the dynamic and the conventional system, analyze if the components and method used would be feasible practically, assess the conditions that would affect the system's performance, and examine any other possible enhancements. So this leads me to my hypothesis, which is that a dynamic traffic light control system would show improvements over the existing system, and using image processing techniques would create a system that's feasible for use in various illuminations, in various resolutions, and would work with the existing traffic infrastructure. Let's move on to the literature review. I started by looking at the literature comparing the dynamic and conventional system, and the results showed that the dynamic system had better performance and efficiency in reducing queue time and length. So next, I considered the different types of research that had been done on the different types of dynamic systems. And with sensor-based systems, they were limited by the need for a lot of additional hardware and the installation, maintenance, operational costs, and the fact that they had a high failure rate. With machine learning systems, they overcame this limitation. However, they were limited by the need for large amounts of data and training. Otherwise, they were inaccurate. With image processing systems, they overcame this limitation. However, as shown in this paper described by Tamid and Hossein, they used the CANI algorithm for edge detection, which uses a Gaussian filter which comes inbuilt with the algorithm. So they noted a lot of false edge and weak edge detection caused as a result of this. So the next paper overcomes this issue by using a hybrid filter instead, which comprises of a median filter. And therefore, this component was chosen for use in my system, as it reduced the weak edge and false edge detection. Another paper noted that the edge detection performance was best in the HSV color space when compared to the RGB color space. So this component was chosen for use in my system. And finally, this paper on the image processing based traffic light control system was seen to be reliable and accurate. Therefore, this framework was chosen for use in my system. However, the processed image here was seen to be pretty noisy. And as a result, my system aims to overcome these limitations by enhancing the pre-processing with a median filter and HSV conversion, with utilizing a real-time feed and with testing on various illuminations, which were not covered in the paper described in this slide. So moving on to the research methodology. The real-time traffic light control system described in this thesis uses hardware and software modules, which comprise of the controller, traffic light and physical module, and the image processing, object detection, counting, and traffic control modules. The hardware implementation of the system was set up according to the circuit diagram shown in this image, and the software implementation of the system comprises this following methodology of image acquisition, pre-processing, enhancement, segmentation, feature extraction, object detection, counting, and LED control. So the Pi camera starts by acquiring feed, which is segmented into an array of frames, making it easier to manipulate. Then for each frame, the images were pre-processed where they're converted to HSV and thresholded with consideration to the hue value. So the way that HSV works is that it's an alternate color space to RGB, and it separates the illumination of the light from the color information. So by doing this, we are able to deal with changes in lighting and be more versatile in its ability to deal with changes in lighting. Next, the frame was smoothed with a median filter, which scans all the pixels in the image kernel by kernel, calculates the median value for the pixels under that kernel, and replaces the center pixel with that median value. So by doing this, it removes any severe irregularities in the image, such as graininess, and this makes it good for use in low resolution images and in low light. Next, the frame is further denoised with morphological operations and the sequence of dilation, erosion, and dilation. So dilation thickens the edges, erosion thins the edges, and by doing this, it removes the white noise near the edges. Next, the image was thresholded into a binary image where all the pixels in the image were scanned, and if the intensity value was seen to be above the threshold value, which is 127, the pixel was set to black, and if it was below, it was set to white. And by doing this, the background is separated from the foreground or the cars. Next, the change in intensity of a pixel is identified from its neighboring pixels, and it's marked as a contour if there is such a change noted. So as a result, the edges of the car were marked as a contour, and the Cartesian coordinates of these boundaries were stored as a NumPy array. And for the coordinates where the contours were extracted, the cars were detected as an object, and a bounding circle was drawn around them. So the position of each object was then checked to see if it fell within the desired region of interest, which in this case is the area spanned by the 4 lanes. So if it's within the region of interest, it's counted, and if it's outside of this region, it's considered a false positive and it's ignored. Then the object is determined to be either on the horizontal or vertical lanes based on its Cartesian position in the frame, and the density value of each lane is incremented accordingly. So if the density is more on one lane, that lane is given the priority. And if the priority exceeds its time limit of 20 seconds, the priority is shifted to the next lane. So the traffic lights are then controlled to turn green on the lanes with priority or red on the lanes without priority according to this traffic control logic. So that was the software methodology of my system. And this was the timeline for my FRT2 progress, which comprised of resource gathering up until May, code development, testing, and debugging up until June, and the final fixes, resource collection, and documentation up until July. So moving on to the results and discussion. The testing used in my system was unit testing to verify the proper functioning of the different software units, such as the image acquisition and the pre-processing. Then integration testing to ensure that the hardware modules and software modules were correctly integrated, and system testing to ensure that the fully integrated result properly meets the requirements. So system testing involved testing for the following cases. In object detection, I tested for bright light, normal light, medium light, low light, and fog. For the traffic control, I tested on the various scenarios of traffic density, such as when the density was more on the horizontal or the vertical lane, or if they were equal, if they were empty, or if the timer was exceeded. And for performance, I tested the queue clearance time for the dynamic system versus the conventional system. So these were the results of my object detection. As you can see, it's able to detect the cars in these various scenarios of lighting. On the left, we can see the confusion matrices for the various conditions in bright, normal, medium, low light, and fog. And on the right, you can see the performance of the object detection system, which is identified by the confusion matrices. And the accuracy was seen to be 94, 97, 91, 81, and 86% in bright, normal, medium, low light, and fog. So this is converted into these graphs, and the graph on the left shows that the system detected the greatest number of true positives in normal light, the greatest number of false positives or false alarms in fog, and the greatest number of false negatives or misses in low light. And from the figure on the right, you can see that the system is most effective in the order of normal, bright, medium, light, low light, fog, and low light. And a further mild performance decrease was noted between the normal condition and the medium light and bright light condition. And this is likely due to the light glare from the afternoon and evening simulations interfering with the HSV conversion and thresholding and causing it to be less accurate. Then another decrease was noted in fog, where the number of false positives spiked, and this most likely due to the occlusion which is being caused by fog, increasing the noise in the frame and messing with the binary thresholding and contour extraction. And the final decrease noted in low light, which noted a spike in the false negative detection, as you can see in the graph, is most likely caused by the lack of lighting, which is a very common performance hindrance in image processing systems as it introduces noise into the system. So these are the traffic light control results, where the LEDs were changed and according to the various scenarios, and they were tabulated. And the correct LEDs were seen to turn on and off according to the respective cases. Then finally, the time taken to clear the queue was simulated and compared for the dynamic and fixed time system with a green light duration of 20 seconds. So the results showed that the dynamic system took approximately 12 seconds to clear and the fixed time system took 26 seconds to clear. And this resulted in a 53.8% queue time reduction for the dynamic system. Finally, to conclude, I would like to say that this thesis achieves all of the specified objectives. An object detection system was designed and developed. It was able to identify the number of vehicles from the live feed. A real-time traffic light control system was designed and developed, and it was able to control traffic light LEDs based on the vehicle count. Testing was performed, a performance improvement was observed over the conventional system, and the system was seen to be feasible for practical use. As it works with existing traffic light infrastructure, it works in resolutions lower than what is implemented. It shows the ability to work in various illuminations. It's less computationally expensive than some techniques like machine learning, and the accuracy is similar to or greater than the sources from my literature review. So the value of this product is that it's extremely scalable and it could potentially be used for practical implementation, and it would contribute to reducing the negative effects of congestion, such as pollution, waste of time, waste of fuel, and mental stress. So these are my references. That is all for my presentation. Thank you for your time. So as you can see, there are currently more cars on the vertical lane than on the horizontal lane. And this is represented on the terminal on the right, which shows the number of cars on the vertical lane is 3 and the number of cars on the horizontal lane is 2. Therefore, the traffic light is set to be green on the vertical lanes and red on the horizontal lanes. If I move the cars to the vertical lanes, you can see that the number of cars is getting updated on the terminal, and the traffic light is still green because the vertical lane still has priority until all the cars on the vertical lane are clear. So now when I move the final car, it switches to giving priority to the horizontal lane. So as you can see, the horizontal lane has been given the green light and the vertical lane has been given the red light. In this case, there are more cars on the horizontal lane than on the vertical lane. So this is represented on the terminal as well, showing that there's 4 on the horizontal, 1 on the vertical. Therefore, priority is given to the horizontal lane LEDs, which are green, and the vertical are red. So when I start clearing the cars on the horizontal lane, when I fully cleared all the cars in the horizontal lane, the priority switches to the vertical lane, and the LEDs have turned green to allow the cars in the vertical lane to go. So once all the cars on all the lanes have been cleared, there is no change in the LEDs. This is the result of the object detection in bright light. This is the result of the object detection in normal light. This is the result of the object detection in medium light. This is the result of the object detection in low light. And this is the result of it in fog.
Good day to everyone.
Okay, thank you very much, Jonah. So I have few questions, Jonah.
Yes, sir.
Okay, number one, alright. So basically, from your objective, you said you design and develop an object detection system able to identify the number of vehicle from a live feed. Correct?
Yes, sir.
Okay, can you show me the result, please?
Okay, yes. Give me a moment. Let me share my slides.
Okay.
Are my slides visible?
Yes.
One moment. Sorry, it's taking a really long time to share.
It's okay, no problem.
So essentially, it's a little bit small, but the object being detected are the cars in circles. And on the terminal, there's a little terminal on the right.
Mm-hmm.
And the number of cars are actually mentioned there. It's a little small here to see, but in the demo, it's I represented it in the demo where I sort of highlighted it. Yeah.
All right. So my suggestion, if you want to present this result, right? So I think it's not very clear to the examiner or to any evaluator who check this project. So it's better you can put in a table. Okay, you show the number of cars and also the detection, so that people can understand clear. Okay?
Yeah, actually, this is the result of the object detection in a table. This one was the graphical one, just to show like a proof of it. And the results of it are here in the different light conditions. So this is whether it was correctly predicted or incorrectly predicted.
All right. Okay. Thank you. It is good. All right. So number 2, to design and develop a real-time traffic light control system able to control the traffic light LEDs based on the vehicle count. Can you show me the result?
Yeah. So this was the result that I got after simulating it in the different scenarios, and the result that was shown physically on the LEDs, and I just tabulated it here in this way.
So what kind of the parameter that you evaluated in this table?
Yeah, so in this table, I essentially detailed the scenario, which in the first case, as you can see, it's when the number of cars on the horizontal lane was more than the vertical lane. Then I considered the condition as well, like initially what color it was, and then after what color it changed to, and whether the green, yellow, and red lights turned on or off. So those were the different parameters. Okay, so the variable here is the scenario, or like the position of the car.
Okay. All right. So next one is to validate the proper functioning of the system by testing, for example, the ability to intelligently control the LED according to the density of vehicle on each lane. Okay, which one?
1 minute.
How you validate the proper functioning?
This one, to perform testing to verify the proper functioning?
No, from your thesis, to validate the proper functioning.
Yeah, so the way that I validate the proper functioning is through the different types of testing, which for the sake of this presentation, I had to cut out the specific details.
So how do you validate? Using which equation or using which paper? How do you say that this proper functioning is okay or not?
The validation is according to my predefined expected outcomes, and the functional, how do you say, the functional requirements of the system. So when I did the unit testing, for example, in 1 minute, I'll share my other slides. I have it listed there in detail, if that's okay.
Okay, I think for objective number 3 you can remove. Okay, because it's not very clear. All right. Okay, next, last one is to model an improvement in efficiency and performance over conventional fixed time traffic control system. That means you show the demonstration is your modeling or what?
Yeah, for this one, I ran 2 programs. One is using this one that I created, and another one was just with a fixed time logic, where there was a green light duration of 20 seconds. So yeah, so the results of this being simulated in those two conditions were the 12.33 seconds and the 26.33 seconds.
Okay. All right. So can you show me the graph which shows the confusion matrix? I not remember what the page. Okay, this one. Yes. Okay, I can see that the purple line. Okay, for the confusion matrix. Okay, the purple line. So what does it mean? Can you explain?
Yeah, so the purple line basically represents the true positives. And what that means is it's compared with the different light conditions. So what that means is basically true positives are like the number of objects that the system has predicted correctly. So in reality, the object exists, and the system also says that it exists. So that's what's defined as a true positive. So it's the ideal outcome that you expect to see. So if it was like 100% accurate system, everything would be a true positive and everything would be a true negative in that case.
Okay. Okay, I think that's all for my question. Thank you very much.
Thank you, sir.
All right. Okay, so next we move on to next candidate is NAIR Rajiv Suresh. Okay, Rajiv. Hello, Rajiv, are you ready?
Yes, sir.
Okay, thank you. Mr. Tachana, are you ready?
Yeah, I'm here.
Okay, thank you.
Good afternoon to one and all present here. My name is Rajiv Suresh Nair, and today I'll be presenting my FYP21 final presentation titled for the topic Remote Multi-Parameter Patient Monitoring System using IoT. So, as we all know, healthcare is an essential component of a person's life. As the saying goes, health is wealth. This means that, of course, health is very important to a person's state of being, let's say. As we all know, healthcare is one of the very essential aspects of life. As the saying goes, health is wealth. This means that without a good shape, without being in a good shape, you will be at a massive disadvantage in any physical, mental, any kind of task. So the problem statement, as I mentioned earlier, is that though healthcare is a very important aspect of life, it is also equally hard to get in equal measure. So it is
I'm sorry
expensive.
because there is some problem here.
Good afternoon to one and all present here. My name is Rajiv Suresh Nair, and today I'll be presenting my FYP21 final presentation titled for the topic Remote Multi-Parameter Patient Monitoring System using IoT. So, as we all know, healthcare is an essential component of a person's life. As the saying goes, health is wealth. This means that, of course, health is very important to a person's state of being, let's say. As we all know, healthcare is one of the very essential aspects of life. As the saying goes, health is wealth. This means that without a good shape, without being in a good shape, you will be at a massive disadvantage in any physical, mental, any kind of task. So the problem statement, as I mentioned earlier, is that though healthcare is a very important aspect of life, it is also equally hard to get in equal measure. So it is expensive, sometimes it's inaccessible, and it's also risky if you see today's the world's current situation where in a pandemic, people are actually hesitant to visit doctors no matter how bad of a time they're having. So this project will cut down on these transportation and hospitalization fees while also making it easy for people who, let's say, live far away from these healthcare providers. The objectives of my research are to design and develop a multi-parameter patient monitoring system using IoT and Arduino, to design and develop a notification system that if it detects the patient's vital signs as not desirable, it classifies it as not desirable based on the readings that it has been trained on as a support vector machine algorithm. And it will notify the doctor who is a user of the system as well in their own dashboard that the patient requires assistance. Finally, it is also to implement a communication interface that allows for communication between doctors and patients while also helping them keep track of these readings. For my research methodology, I'll go over how each component of my system was made. Firstly, the monitoring system consisting of the Arduino, the Node MCU ESP8266, as well as three sensors. One sensor in this picture has been deprecated because of its readings being taken from another sensor. So the heart rate sensor, the one that is specific to heart rate, is deprecated because another sensor measures both heart rate and SpO2. So first, these components were researched, they were purchased and tested individually on the Arduino before their code being compiled in order for them to all work together using I2C or integrated chip communication using SDA and SCL pins. So after that, the data from these sensors were tried to be sent to the Node MCU via the Arduino using UART protocol. And after this was done as well, the data was sent from the Node MCU to the ThinkSpeak cloud server, and the sensors, since they were finalized and were not faulty, were sewn onto the arm sleeve, which is used to wear the sensors in close contact. Secondly, the communication interface and the classifier. This revolves around where the first point of research in this was to research the number of papers, not papers, sorry, the pages and or screens that are to be involved in my interface. So I had to first make up the interface, create a user sign-in page, sign up and log in, a dashboard where the data was to, and finally, after this, the classifier requires for a relevant data set to be found that matches what I'm trying to do as well as the parameters I'm monitoring. I had to create the model. I had to train it with the data set as well as test it with the remaining data, analyze the data from the sensors using this model, and then classify it as whether stable or unstable reading. If it's unstable, then it gives the doctor user in the interface a notification. And if it's stable, it straight away goes to receive the next record for classification. The data from the web server is stored into a local database from where the database is populated. A dashboard is populated. I'm sorry. This is the results of the monitoring system. On the left, you can see is the arm sleeve where the sensors have been sewn in. They have been connected to the Arduino and the ESP8266. On the right is a serial monitor showing the output of my Arduino, which will later be seen in better quality in the live demo at the end of this presentation. This is the communication interface. On the left, you can see the dashboard where you can see the graphs showing the information for each parameter being monitored. On the right, you can see me in the video conferencing part of the interface. I'll go through this as well in the live demo. To conclude, this project discusses the creation of a multi-parameter patient monitoring system that remotely monitors a patient's biotelemetry and provides not a diagnosis, I'd say, but like acts on this data by notifying the doctor as if the patient it determines that the patient requires help. This is done using a support vector classifier that is trained using a data set, and this is implemented in a Flask application where not only can you view the data, but also you can have a consultation with the doctor via video conferencing. So as this project, in this project, I have I've partially achieved all my objectives, at least to a particular degree. The first objective, which is to create the system, has been successful because I can read data from the sensors, send it to the cloud, and read it on my dashboard so I can monitor data. Second is to create a notification system to classify the data as good or bad. This has been partially successful because I can notify the doctors, but based on hard coding the rules, basically, by instead of having a machine learning algorithm classify it as good or bad. This is because it was actually really hard to find a data set that fit my exact requirements, and most of the data sets didn't have a label to classify them, so I couldn't train the database. Sorry, the classification model. The third objective for creating the communication interface as well as the video conferencing feature is again successful, as can be seen in the live demo. So lastly, I'd like to say that this project contributes to people who cannot afford hospitalization due to their financial conditions, people who cannot access these healthcare due to their where they live, or because they don't want to go out to hospitals to receive conditions in such an environment as we are experiencing today. This system is an alternative to most major systems, which cost almost 10 times the cost of the system, which has, in my report, I've written that it has cost me 122 ringgits in components, which is again like a tenth of the cost, if not less, of the major companies such as Medtronic and Honeywell. And obviously then it is very beneficial to its niche as it provides more components or features than its counterparts. Thank you. Good evening, dear examiners. My name is Rajiv Suresh Nair, and this is a video demo of my FIP project, a remote multi-parameter patient monitoring system. Here is the monitoring system setup. This is the Arduino and this is the Node MCU, which are both plugged in to the computer just to show you the serial monitor outputs. Otherwise, just the Arduino would be plugged into a power source via USB, and the ESP would be connected to the Arduino using its own power pins. Moving on to the sensors, I have sewn on the sensors onto an arm sleeve, so it's easier for a patient to have them on them as they are non-obtrusive sensors. I have another sleeve which goes on top of this one, so you don't see the wires as much and can be worn without it looking like a mess. Just for demonstration purposes, I've not kept the other one on. This is a heart rate and blood oxygen sensor connected, soldered together with a temperature and blood pressure sensor. This is a stress sensor which will be monitored by checking the capacitance between two of your fingers, and they are all connected using I2C or integrated chip connections, where they use SDA and SCL along with VCC and ground pins. The Node MCU connects to the Arduino using UART protocol, and the Node MCU sends data to the IoT platform using Wi-Fi. Now I'll show you a screen recording of the serial monitors outputs for both the Arduino and the Node MCU. Before I move into showing you the screen recording, however, I'll have to show you it actually being connected to the patient, like so. So on top of the sleeve, you're meant to wear the other sleeve so it blocks out the other wires. Later in a later revision, I'll try to get wire insulators so I can have a seamless single wire coming out instead of multiple. And this is the stress sensor, which has an anode and a cathode, which measures the capacitance between both fingers. And the other sensors are inside, measuring heart rate, temperature, blood pressure, and SpO2. Connected to the Arduino, which is in turn connected to the ESP, which is then being read to the serial monitor connected by USB on the computer. So this is what the lap is being captured from the laptop screen. This is the Arduino IDE, and currently this is the code for the Node MCU or ESP8266. In its serial monitor, you can see that it's sending this data to the cloud or the ThinkSpeak's IoT platform, and it gives a channel successfully updated message every time that it does successfully update. Um, Moving on to the ThinkSpeak cloud, as you can see that the data has been collected here and it's being then constantly entered. There are some bad entries here and there that spike. I mean, not this, but for let's say SPO2, where the value goes above 100, but those values are accounted for as the majority of the values are consistent. So next I'll show you my interface, which is here. This has been created in Python using Flask, and yeah, so I should run this now. Okay. But if I choose, I can use a utility called ngrok that allows me to deploy this on public URLs. This is completely made in Flask, which is then made using HTML and Bootstrap. So this is the live data from the sensors. As you can see, it's being dynamically updated over time. And this is the spikes of high readings that has been classified according to the classification model that reads for valid data between a certain range, and hence it doesn't matter if you get random values or bad values such as this, because it's clearly a fault with the sensor and not a false positive. So next I'll move on to the meeting section of my third objective, which is where you can talk to the patients, or the doctor can talk to the patient over the internet using this interface. This can be accessed through the meetings tab. Right. Okay. There was a conflict between the camera for my screen recording, which is through MST, and this. So as you can see my face here, and I can type my name in, and I can join a chat room which is created specifically between me and the other person who accesses this place. And I can go into my terminal, my local host into public URLs. So that means anyone with this URL can join the video call with me right now. So to demo this, I'll send this to a friend who will then, who you can see join the video call. So now I've shared the ngrok link that I've shown earlier and with a friend, and now you can see her in another window in real time. This is the patient, and there's also a chat where we can toggle type and share screen, but that is an extra feature. Thanks, Aha. Okay, so that was it. Thank you.
Okay, thank you, Rajiv. So we can start the Q&A, Mr. Tachana.
All right. Yeah, thanks, Doctor. Right. Good afternoon, Rajiv. Right. Rajiv, I have a few segments to discuss with you. There's two segments. One is on your report. Okay. There's another one on your application. That means your demo. Right. So I don't take long because I will put all the comments about the reports on the evaluation form so that you can go through and you need to amend that part. Okay, that's so many things you need to amend that. Okay, so I don't want to share here because it takes not long, right? But I just want to clarify a few things before I go into decide on the evaluation form. Certain things, because your title is the title is more remote sensing design and implementation of multi-parameter patient monitoring system using IoT. When I'm looking back at your objective, okay, and I'm really appreciate that you honestly you mentioned that you're partially success on the SVM part, okay, because I see on the first objective to develop a develop multi-parameter patient is done, okay. I can see from the demo or even from the document what do you call thesis, okay, it's successfully delivered, okay, okay, it's good. But second thing, to design and develop a notification system, notify doctor about their patient condition if it's fall below specific threshold, right? Okay, your title, it's very interesting and it's very challenging, okay, because your second objective, okay, if you would succeed your second objective, I would say I think you can go places, you can bring this project to the commercialize, okay. But since your second objective is not fulfilled, okay, due to, okay, correct me if I'm wrong, because when I go through your thesis and your demo, some is tally, some is not tally, because you're mentioning that we are using this remote sensing for monitoring the patient, so they don't need to walk into the hospital. So we will use these what are the devices, and then the signal, the sensor will be upload into the what do you call desktop or mobile, okay, through the interface, and then doctor will get notified in case there's abnormal signals, right? But I can see your first one is succeed, your second one is good. That means you can communicate to the doctor. When I check your literature review that you mentioned clearly, that's very good as well. That you mentioned that all the latest literature review up to 2019 or 2017, they developed interfaces using Arduino with IoT, and but there's no interaction, which you came with the solution for that. Okay, it's very good that I can see the both that you can interact. But what I can see now that something is missing when you look at the title and look at your outcome now, the second objective is not fulfilled. So I prefer, because I can't see from your diagram, if you mentioned that the signal is already uploaded, okay, into the cloud, and then from the cloud I can see all the the graph, okay. But as per the second objective, we need to see how the the training data to be experiment to see whether the patient acts got abnormal signal. For example, he got some high pressure. So how to implement onto the screen, how to show that. So that part is missing. Okay, as per your title, I'm not saying because you already informed to us that according to the demo that you are partially fulfilled. I agree that, but according to the title, and now I just want to clarify with you, so that part is missing. That's why I'm saying if that second part is clearly delivered, I think you can bring this project to go places, you can commercialize, because it's a wonderful project which is very demand, okay. Because as per the literature reviewer, I can see all of them, the previous author, they did on the develop interface, even, yeah, they did the using the sensor to identify the signals using the patient, but there's no interaction. But I can't see SVM part on the literature review. And yes, some of the authors, they came with the succeed with the SVM, but in other algorithm, as per my reading just now. But you are using SVM, so that's the part I'm very sad, and I can't see the work at in the project. Okay, so what I suggest now, we need to rephrase on the second objective. Don't want to be there, and your title and the second objective, it will be if no tally, then the outcome of the thesis will be it's not rational. Okay, so we need to rephrase on the second part, because you said partially. I can't understand also partially, because I can't see exact SVM part on the over there, because I can see the as example patient lie down, and you said that's wiring there. Okay, it's goes sensors goes there. I can't see what would be the step one, step two, step three, how the signals goes in the interface. You understand or not? So what I can suggest, yeah, first thing, I need you to rephrase the second, talk to your supervisor, rephrase the second objective. Second, I want you to screenshot in detail what have you done with current one, except the second objective. What are the work you have done using the first objective, second objective? I want you to screenshot in detail. That means how from the patient, you put the wiring right from the first you are connect to the Arduino. What would be the first screen pop up in the interface, second screen, third screen, and then how the cloud will go, so that you put it in the back in the documentation. It clearly, like myself, I'm not engineering, but when I see that, make sure I understand that. You got my point, or not? But as for the computer science, myself computer science, I can understand about the SVM part. So engineering part, yes, very good. That's why I would say that I appreciate that you fulfill the first objective. You came out with the Arduino and you connected everything done. Very good. But I need to see in detail about the screenshot part. Okay, that's the first thing you have to do. Second, rephrase the objective, and then documentation. I don't want to talk here. I will put it in the evaluation form so that you will check one by one and amend on that part. Okay, there's one more. I need to check with you that. Yeah. Uh, you mentioned that you done what do you call it, the chart, something I can see from the thesis that something for me, correct me if I'm wrong, it looks like a testing, but I can't see the user acceptance testing as well. You understand, if you how many patient you are used for the test, for signal part, so that part as well have to be update in the documentation. So kindly take note the UAT, user acceptance testing as well. So how the response, accept the support recognition. What would be the first objective, third objective? You use the first one, third one. According to the first and third, what would be the user acceptance testing? How the response? How you upload in the cloud? So that part you have to be, you have to come up. Is it whether it's accepted or not accepted? What are the connection part? Okay. So that's all about your application. Report I will write for you in the evaluation form so that you can go through it. Okay, that's all. I think from my side, Dr. Ahmad.
Okay, thank you very much, Mr. Tachana. So Rajiv, please take note all the advices from him. Okay, so next we move to Ruckhika. Ruckhika, are you ready?
Yes, sir.
Okay, hold on.
For FYP2. In this presentation, I will be presenting an Android-based expert system application associated with camera-based math detection and solver. The intent of this project is to develop a program that is faster, more efficient, and conducts an intuitive approach towards solving mathematical problems. This app is developed for mobile phones with a functional camera and running on an Android operating system. And this report will describe how the goals and objectives of this project were achieved and the application, which is given the name CamCalc, was developed. So as for the background study, mathematical equations are a cornerstone of everyone's life, be it what we learned in nursery, writing numbers and solving it by a traditional pen and paper methods, to us learning in middle school or high school using calculators, to even more recent technology, which is exactly what's proposed here. So yeah, as noted by Hussein and others, rapid progress and improvement in technology thus far. Still, handwritten mathematical expression recognition is one of the complicated issues in the area of computer vision research. This is something that we will tackle in this report, because as we go further, the problem statement and objectives. So the focus of this project is to develop an Android application in which the user could capture pictures of mathematical calculations, and the program would then, utilizing OCR and concepts of CNN, detect the mathematical problem within the image and proceed to solve it and provide the user with feedback on the proper solution. So yeah, during the preliminary research, when a survey was performed, it was found that even though calculators exist with the sole intention of solving mathematical problems, there are some limitations to it, such as mainly being human effort put into manually inputting the factors of the mathematical problems, but end up becoming cumbersome and prone to error. Also, there already exist mobile applications available for such equation solving. However, these applications are mostly in the form of predefined areas and users enter numbers into static text boxes in place of equations to calculate it. While this is effective, it's also extra work. Whereas, as proposed in here, capturing the problem directly by the camera and solving it would be a much more time-saving and intuitive approach. So this project aims to tackle that problem by implementing a method for the input to image based, thus reducing human effort and time required. Problem statements are here as followed. Uh, the objectives are here as follows. To capture an image through the device's camera and detect the mathematical functions and figures specified within it, to perform mathematical calculations in real-time basis, and to display a solution to the user or display an according error message. So yeah, the scope of this project focuses mainly on students of varying ages who deal with a lot of mathematical calculations. However, it is not only limited to such. There are various everyday calculations that take place in real life by people from various walks of life. Some of them do them mentally or manually, while others would just whip out a calculator or phone and enable them to do the calculation. Well, actually, as per the research that was the research survey that was conducted, it was found 66% of participants said they use calculators for even simple math, as such as what is 10 divided by 5 minus 2, stuff like that. So there's definitely a niche for an application like this right now. As for the significance of study, there's already been done very little research on the topic of a camera-based equation detection and solver app for mobile phones. Therefore, I do think that it's significant and important that appropriate topic to further look into and to develop. There already exists an application called MathPig. However, its code is not open sourced and cannot be referred to. And as stated in by Onishka C in his paper about MathPig, the one limitation of this app would be that it only parses one line at a time. Moving next to prior and related work, optical character recognition. So OCR is a tool that's used for extracting text off of images. This technology contributes much towards data analysis due to its ability to rapidly generate digital output of an image. Well, there are not many OCR algorithms that could be utilized for mathematical expression detection, but the ones that do are mentioned here. And as seen here, the OCR that was chosen was Google Docs, as it has the best output available, 7 out of 10 images for the most level of accuracy compared to the rest of it. Well, in Google OCR, there are 2 components of it that are more relevant to the report here. Text detection. This helps in detecting and extracting any form of text inclusive of numbers, digits, and mathematical operands from the captured image. And in this, the JSON would include the entire extracted string and would also take note of the bounding boxes, example as seen here, for each of the individual words. So that provides much accuracy and is also easy. There's another one that could be implemented in this document text detection. However, in this project, this is not used. Moving on to CNN. So among all image recognition problems within computer vision, handwritten mathematical expression recognition is one of the most complicated issues. According to Yamashita and others, CNN is a class of artificial neural networks that have become dominant in various vision tasks and is extremely useful in handwritten character, words, numbers in a way that could help in automation extraction of distinct features, and this makes CNN the most suitable approach. In this program, I've used from mathparser.org the parser MX, and it's with version 4.4.2. This is successfully implemented and is working with ease. Well, the development Android Studio was chosen as it is directly connected to Android operating system and allows for direct development from there. And it also has an inbuilt emulator, which means that you don't have to like test it on another device. You can test it in the program itself very perfect, and you can select devices, and it would work across a various range of devices. Therefore, Android Studio was my chosen platform to develop this project. Well, next let's talk about the software development lifecycle. So software development lifecycle is one of the most important um part of every software project development to ensure maximum efficiency in the project, given the highest quality for lowest cost and time. For this project, I've chosen to implement the iterative cycle as it is the easiest, since you have to since each iterative cycle you can keep coming back and correcting things and still making changes. And as a beginner programmer, it is extremely useful. So while talking about the particular iterative cycles, there are four of them. The first is processing and detecting the math functions in the captured image. This would be the first cycle, and upon coding and implementing of the Google OCR algorithm for this task, it would be tested to see if it is working, and then we would move on to the next, which is performing mathematical calculations where MX parser was used, and to see if the images that were captured by Google OCR were properly calculated. And upon finalizing this, we moved on to the third iterative cycle, where the solution and error message are displayed to the user. Actually, for the fourth iterative cycle, this was developed across, we see the Gantt chart here, across a wide period of time, not just after the third iterative cycle, because the UI was designed earlier itself, and upon completion of this, it was then integrated with it. And to make the program more concise and the UX experience very nice. The hardware software requirements are as followed. I used an HP laptop with an AMD AP9420 Radeon R5 processor to code this, and it would run on any Android device, which is a later version than Android Ice Cream Sandwich version 4.0, and has 12 MB of free space and a functioning camera. The software used to develop is Android Studio with Java environment, and it would run on any mobile phone with an Android operating system. Here's the Gantt chart, and everything was accomplished as followed, with minor tactical and technical delays, but the program is completely finished and ready right now. This is a user case diagram. So basically what happens is the camera clicks an image. OCR recognizes the what's specified in the image, and the MX phrase parser would use it to find, like, either get a solution or it would not recognize it, so it would provide an error message. Either way, it would the appropriate solution would be displayed, or an error message would be displayed as an output to the user. Well, to save time, since we're on time limit, to summarize exactly what was found by the requirement gathering phase, is that 71.4% of the responders prefer mobile phones to calculators than assistive devices, and a large number, 66.7 and 90.5% of the members who responded said that they definitely do use computational devices on very simple and also very complex problems. And a 57.1% said that they do think that assistive devices have an impact on their productivity, while 38.1% said that they did not notice about it. Further, 56% haven't thought about any possible implementations, but 40% of them did think that current mobile app and calculator systems could be improved on, and these are the suggestions that were given as to what improvements could be done to the existing system. Well, next, moving on to the UI and UX design. So yeah, the user interface of CAMCALC was designed keeping in mind that it might look different on different devices. So this is a Samsung Galaxy J7 phone with the device screen setting set to dark mode, and this is a this is how it would seem on a Redmi Note 8 phone with the device settings set to day mode. Furthermore, during designing of the UI, the color purple was taken into consideration due to the fact that it's considered a neutrality, whereas colors like red or anything bright must come across as too harsh and distract the user from the application's functionalities. The features were designed in also like a streamlined and concise manner with no unwanted elements or distractions. Moreover, CAMCalc is designed very much to the point and to satisfy the all of the objectives that were mentioned. Much thought was also put into the name CAMCalc. CAM, which stands for the shortened version of cameras, combined with Calc, which stands for the user interface works, is that you can click the camera to scan an image, as like for example seen in the previous slides as well, and it would automatically get the the calculation that the math problem that is like specified in the camera in here. And one advantage, one quirk for this is also that once the OCR detects it, you can still manually correct whatever the OCR might have done wrong. Or you could also like instead of utilizing the OCR, you can by yourself just manually type in as well. So that is a quirk that it could take just normal input functioning as a normal calculator, and it could also take a visual image input. So next, before moving on to watching a demo, we shall also discuss the conclusion and the results of it. So under results, TOCAM calc is working properly. It does have certain limitations. For example, like simple linear equations with like multiple same type of variables, just 5x into 5x plus 5 equals to something, it would find the x value properly, yes. But calculations with two varying variables, just x and y, in the same math problem, they weren't performing successfully. Furthermore, the squared function was working via manual input. It was hard to detect via OCR. Like out of 10 attempts of it, only 2 of it was working properly. And it is also to be noted that even with manual input, complex forms of equations such as 5 square into 40x equal to 500 was something that the application could not perceive. The main reason being it is still in its initial phases, and this was developed just for this final year project, and further improving on and developing it is definitely in the plans. So yeah, the OCR element has a hard time distinguish between the equal sign and also the multiplication sign in some of the handwritten words. But most of the times, if the OCR had struggled with detecting it, upon retaking the same picture, it had detected it just fine. So as to conclude the final year project, all of the objectives were successfully achieved. Furthermore, further developing this and further improvements could include being able to compute complex equations and being able to include graph functionalities and all scientific annotations. So now let's check out the demo. So yeah, this is, for example, this is like an empty picture. There's nothing in here. It shows an error of image was not updated. So obviously these are not all of the test variables. All the test variables are found in the appendix part of the report. These are merely just some of the variables that with different kinds that I have chosen for demonstration purposes that the app is working. So yeah, manual input is also working as seen before, and this is, for example, a technical design error thing. It should generate an error, and as expected, it did generate a math error, and that is an example of a handwritten image. Next is a typed out equation of 100x minus 0 equals to 200. So yeah, the app correctly determines it, and for the first time, it showed x equals to 2.0. This is an example of a simple calculation. And it shows the value in negative. So just skipping this for like time purposes since our the time is running out. So yeah, it functions as required. Next is a bit more complex equation. This is the same equation that we had seen before, but in a different font. Yeah, for this, it did not immediately show that 100 into x equal to, it should have showed 2.0 in the previous year. So 2.0, it did not show it. So it shortened it just did half of it. And again, while pressing compute, it showed a math error. But compute this, it might still show a math error. But then what you can do is like manually type it 100 into x equals to 200. Now it would properly compute it as x is equal to 2. Therefore, this the fact that you could manually type in and even the OCR thing can edit it, it's a very helpful factor for this. So that's all the examples in this video for today. There are more of the testing and the test variable used in the appendix of the report. Thank you so much for watching. That's all from me. Have a nice day.
Okay, thank you, Ruckhika. All right, so I would like to invite Miss Aparna, okay, for the Q&A.
Hi, good afternoon. Ruckhika, can you hear me?
Good afternoon, ma'am. Yes.
Hi. Okay, well, good attempt. Nice project.
Thank you, ma'am.
First thing, I would look at the challenge of the input data itself. I see that you can take, because the drawback of an general OCR application is the input data. It recognizes mostly if it is printed rather than handwritten, right?
Yes, ma'am.
So when you do the handwritten, your system can take both, right? Handwritten as well as the printed.
Yes, ma'am. Yes, ma'am. I have included all the handwritten things in the handwritten test variables in the report actually.
But I see some challenges there for you. One is it can't recognize different handwriting, small fonts, and all those things. And then you're also saying it can't recognize some of the mathematical symbols like
Uh,
multiplication equal to,
it's not that
right?
it can't recognize, ma'am. It could recognize it, but out of like testing about 10 cases, one or two we had to retake it. Like once it would show like it would take in a different output, but then when you retake it, it mostly in almost all the times I've tested, it has worked fine. Just that you have to take it again.
It can also solve complex expressions and scientific expressions.
No, ma'am. It cannot do that. Not for
No,
now.
right? Only simple. But if you give like a
Yeah.
BODMAS expression where there's a bracket and multiple set of operators, it can't solve.
No, ma'am. It
So
can't
it's
solve.
basically for a very simple expression, right?
Yes, ma'am. It cannot
Okay,
handle
okay.
various variables also, just one kind of variable.
Right. So when you did your literature research, you looked at different applications.
There weren't many applications that were available for me to like look at, ma'am, and the ones that
Ah,
were there, none
okay.
of it was talking in detail about how exactly it was working. So I had
O-
to take this from scratch,
Okay,
actually.
okay. Because I see there a missing link. There is not much that you have covered, and you have seen only a few things, right? And there is no
Yes.
table where you are comparing and writing. If you can just add that table, because
Mhm.
whatever you have seen, you have surveyed a few things, right? If it
Yes,
is
ma'am.
published and if you can show it in a table, even if it is little done on this, because
Oh,
your system is also simple, but you have to show that it's an improvisation on what is already there.
all right, ma'am.
Yeah, if there's a table missing there in your report, that's the first thing. And second thing is this is just it can handle only simple equations. You're clear about that, right?
Yes, ma'am.
But then your title says it's an expert system, right?
Yeah, ma'am.
So you're calling it an expert system. Wait, let me just go back to your report. So Android-based expert system application. So when we say expert system, we are looking at something that, can solve complex things. Okay, it's basically designed to solve complex problems and basically emulates decision-making ability of a human. So maybe you just want to reconsider changing your title.
All
And
right.
then it's a problem solver for students in MIU only.
No, the survey that I took and everything that was based on MIU, ma'am. So that.
That you can put it, but in your title, maybe you don't want to mention that.
All
Right? In your title, you have said, right, for students in MIU.
yeah.
So it's just a general application, right? It's not just to be used by students in MIU. So if you just want to think of the title, just rearrange your words, maybe expert system, you just think about it. That's one thing. Second thing is this. And in your approval page, you have written you're going to get award for degree of Bachelor of Electrical and Electronics Engineering.
Oh no, no, ma'am. Oh, I shall. I got the
Yeah.
format of it from someone.
Okay, okay. Maybe change it because you need to change the degree name.
Yes.
Okay, so just change. There are few things in your report as well, which I have pointed out, but this is degree award is really a very major thing. So please change that name. Okay,
Yes,
that one. Second thing, your topic, just rethink, and if you want to reframe it, please do. And then in your abstract also, I found a few things. I'll point it out in your report when I pass it back to you.
sure.
There also you can have a look, and then I definitely put a table where you are comparing
The
the
existing
different
work.
yeah, what is there, how is yours, and improvising. Even if it's little improvisation, it would be helpful to see.
Sure, ma'am.
Okay, so just that much only from my side.
Thank you, ma'am.
Yeah, well, bye bye.
All right. Thank you, Miss
Yeah,
Aparna.
yeah, well.
Okay, so Ruckhika, please take note.
Yes, sir.
Okay. All right. Okay, so next we move to Sahara. So Sahara, are you ready?
Sir, I am.
Are you ready, sir? So Sarah, are you ready?
Yes, sir, I am ready.
Good morning, respected lecturers and my fellow presenters. Today I'll be explaining my FIP thesis, which is Design and Development of Time Scheduler for University Students that utilizes NLP. So I'll be talking about introduction, literature review, methodology, results, conclusion, and references. And also I'll be giving a demo of my project. So first abstract, time management is a critical skills in students' life. It is very important for students to manage their time in order to have a proper schedule and also to have a better academic achievement, because due to a lot of researches, it has been proved that students' academic achievement and time management skill is closely related. But some students may lack skills of handling the task and may also lack skills of time management. So due to this, I have come up with a task scheduler that uses prioritization algorithm and time allotment algorithm in order to schedule time for students that will help them finish the task on time. It will also help them improve self-organization. So the problem statements are: students are unaware about importance of time management skill. They know that they need to submit the task on time, but they might not know how to manage their time and what is the importance of managing the time. Students are very likely to procrastinate while doing their task. But some students are there. There are some students who are likely to prioritize and prioritize their task and also have goals, but they are unable to implement them. They need some guidance to do it. And another problem is good management of time accounts 28% of variance of students' GPA compared to students who don't. So students need to have time management skill in order to improve their academic achievements. So in order to solve this problem, I came up with two objectives, which was to develop an app for Android devices using Kiwi
And next one was to design and develop a task scheduling algorithm utilizing NLP. So significance of study is this project dynamically shifts in reorganizing tasks as new entries are made. It also helps to set priorities for the task, and it also helps students form a daily schedule to complete tasks. So I ask students to enter a time where they want to start studying every day so that it forms a proper schedule and a fixed schedule for them to do tasks that will form a habit, and it will also improve their time management skills. Next is literature reviews. I have reviewed some of the papers. The first one is impact of time management behavior on undergraduate students. So different technology about correlation analysis, regression analysis, and time management behavior scale was used in order to find links between time management skill and academic performance of students. So it was found that students may set goals and priorities, but they might not have time management skills. And some of the limitations were studies done with limited population. Another paper is time management and academic achievement of higher secondary school students, and the objective of study was to find a connection between time management and academic achievement. The important findings was with respect to students' academic achievements, their gender and race plays no role in determining their skills in managing time. So every student need to have time management skills and need to learn time management skills. They are not born with those kind of skills, so they need to improve over time. So another paper is the impact of time management on students' academic achievement. It was to establish a link between time management and productivity, and also with students' academic achievement. So it was found that time planning, time attitudes, and time wasting were three major factors of time management, and academic attainment is closely correlated with all time management behaviors. Another research was on STRU-Logger application, which was used to help students by helping them keep track of their finances, which also kind of helped them in time management or building time management skill. So another paper, I'll explain it in a bit detail, because this is so my schedule kind of fulfills a limitation that this application doesn't have, which is SnoopMe application. So this application is a smart application that helps students manage their time. It helps manage their time by setting reminders about student tasks, and also it tracks users' behaviors on mobile to remind them not to use mobile for a longer period of time. So the limitation was it doesn't schedule the time to complete the task for students. So it just is based on if student adds their task and how much they allocate it by themselves. Next is methodology. The software and hardware requirements are PyCharm, Kiwi, SQLite database, and Bulldozer. PyCharm to write codes. Kiwi and KiwiMD was to design the application. KiwiMD was used for Kiwi, which is a material design that helps in optimizing code for Kiwi and also makes the app look better. SQLite database to capture the data of users, and Bulldozer to change Kiwi file to APK. And hardware was only to run application, which was on Android smartphones. System flowchart. So I'll be talking about the profile creation. So users have to insert their information such as email, password, and username. They also have to give extra information about their current program and current semester. They have to give the GPA, time to start studying, and number of tasks they want to perform in a day. And they also add the subjects that they are currently enrolled in. And after they sign up, they'll be redirected to homepage. Adding new task. If they add a new task, they have to give some information about what type of task is it, its due date and marks percentage. And if they click on add task, the task will be added to database, the priority will be calculated, and time will be allotted. Next is how time is allotted. So after users add the task, the time will be allotted for task in the schedule, which will be seen in homepage. And if they add another task, the priority is calculated and also the time is allocated according to the priority again. So this happens only before the time for students, like the student studying time. For example, like 5 p.m. If the student has another task before 5 p.m., then the time is recalculated. Otherwise, it is not, because the student will already have started doing their task. So next is use case diagram. So users can create profile and add tasks to scheduler, and application can do dynamic scheduling. There's some problem with my application, which I'll be explaining in conclusion, why users could not add notes or provide application could not provide reference and also create directory. So the results are the task page where users need to fill up a form in order to give task details, and the prioritization algorithm and time allotment algorithm will schedule the task and show it in the home page. So in the home page, only the number of tasks that the student wants to do in a day will be shown, and the time also will be allocated only for those tasks. But priority will be set for all the tasks in order to calculate which one has the highest priority. So these are the additional features, which is GPA calculator. Students can find their, if they want to estimate the GPA for the current semester, they can use this GPA calculator. I have also built a calendar page where users can add events, so they can choose any date and click on the particular date to see if there are any events or not. So now for chapter 5, which is my conclusion. So this application was made using Kiwi library and successfully run in Android devices. The code was written using PyCharm and used Bulldozer to convert Kiwi program to APK, which was installed in Android phones and ran. The time scheduler was successfully created using task prioritization algorithm and time allotment algorithm. So from this conclusion, it can be seen that I have completed one of my objective, which is creating an Android application using Kiwi. But for the another second objective, I have only achieved half of my objective, which is creating a time scheduler using prioritization algorithm and time allotment algorithm. Now I'll explain why NLP feature was not successful. So the NLP feature is not integrated in my app right now. First problem was logical implementation for this feature could not be correctly applied. So when trying to identify similar words connected to like the topic of my subject or like the subject itself, it didn't give satisfactory result. I used libraries like Spicy, Genshin, and also NLTK in order to perform these, but the results were not satisfactory. And also when I tried to integrate whatever I did with the app, the app failed when I changed it into APK, because there was incompatibility of the URL calls with the device's browser. So the application had to read keywords from the document and then use the keyword to search for references in the browser, but the URL calls with the device browser was not compatible, so I couldn't integrate the code that I had written for NLP in my application. And also there was one more problem. The system prevented apps from accessing the internal storage on Android devices and higher because the storage is encrypted. So the whole concept of me making folders for students to add their related documents and read from them there to reference to give them references was failed due to a limitation in an Android version. So that's all for my thesis presentation. I'll be showing my demo for the application. So now I'll be giving the demo of my application, which is SPST Scheduler. So this is the login page where users can use their registered email and password in order to log in. If they don't have an account, they can press sign up. And for this demo, I'll be making a new account to show the sign up page, like how the application works. So I need a username, email, password in order to sign up. And I also need to give extra information such as my program, current CGPA, semester, start time means when users want to start studying, maybe at 5 p.m. And number of tasks means how many tasks they would want to do in a day, so 2 tasks. Okay, and then now you can enter your subjects that you are currently taking. So code, name of the subject, credit hours. You can press add next. Again, course code, course name, and credit hours. So once you are done adding subject, you can just press done and then press OK, and then you'll be redirected to the home page. You can press add task button and then add a new task. So here, give the name, type of the task, subject, marks percentage, and also a calendar to select date for the task, and then you can press add task, and the task will be shown in the home page with the allocated time from which the users want to start studying, which is 5 p.m. If I add another task with higher priority, uh, then it will be scheduled, sorry, big data, and then marks percentage, and then maybe I'll put a date beforehand so that it will have higher priority. So if I see in the homepage again, there's a difference because since the second task has higher priority, it will be assigned to do it first today. Now next is you can delete the task if you have already done with the task for the day. So if you click on the task, you can see the details. Due to the problems that I explained in my thesis presentation for the references, I couldn't show references in this area. But you can delete the task using these two buttons. One is done for the, that means you still have tasks to do and you want it to be assigned again in the next allocation of time, and completed means you're already done with the whole task and then you are ready to submit it. So now I'll just press done for the day, so it will be deleted from the list. Now I can add event. So event can be anything that might not be related to the university task. So select date, maybe 23rd, and from 12 p.m. to 2 p.m. and then you can add task. So if you want to view the task, you can go here and then 23rd, yeah, 23rd of July, you can see the events that are scheduled for that day. And here is a date picker or calendar picker, so you can go to any date you want where you might have an event. Go to that month, you can select, and you can view events for that particular calendar. So with whatever date you have selected, the calendar changes accordingly. Next is a profile page where users can view their details, and then the profile page is still under development, so you can't change the username for now, but later they'll be able to change the username, email, and password. Next is GPA calculator, which is supposed to be my additional feature in the app. So first I'll add credit hours for all the subjects, and then I will put my estimated grade, A plus, maybe B plus, and maybe C plus. Subject is optional. If you want to enter it, you can. If you don't want to, it's fine. It will still calculate. So if you calculate, it will show you GPA, which is 3.49. So this is all for my demo for my application. So if you log out, you'll be logged out, and you'll go to the login page and you can log in again. So thank you.
For FYP2.
Okay, thank you, Sahara. Now I would like to call Mr. Satya. Do you have any question?
I'm here. I hope Sahar you can hear me.
Yes, sir.
Yeah, the thing is, right, I gone through your document, right. To be honest with you, I have right the same questions in my mind, right. I appreciate that you addressed those two things. Our first objective is to implement an app which is powered by NLP or some AI. I don't think that we are able to achieve that at the end of right our FIP2. And the third objective is right. Okay, you wanted to see right how this app will be loved by right
Oh, that
our
helps.
students. Yeah, we need to do some survey. So right, you mentioned that one as an objective. That's why I'm asking this question. So if you say something as objective, right, you need to address that objective. Okay, so here I think that right we also unable to achieve the third objective. So what basically we done here is we able to design an app by using Kiwi package. Okay.
So for the third objective, I removed the objective from my FYP
Mm-hmm.
um, after the yes, after my proposal presentation, the second proposal presentation, because I realized if I need to figure out the usefulness of the app,
Okay.
a student
Actually, right.
needs to use
Yeah.
a student.
Uh, I'm so sorry, right? Actually, I haven't seen your actual document, right? Yesterday, day before yesterday, right? Ma'am sent your document to me, right? In that objective is still there.
So that was like just a draft because I hadn't finished my the full.
In the draft it is there, right? Then make sure that you talk with your supervisor and please adjust your objectives, right? Objective, I think we achieved only 2, so you can rename your entire project and you can redefine the objectives. I hope you can do that with your supervisor.
Yes, sir, I will.
Otherwise, with these objectives, with your documentation, we are unable to achieve, whatever our stated objectives is. That's why, I need to cut down, heavily on your marks, I don't want to do that. That's why you please talk with your supervisor and change the name and as well as objectives so that, I can reevaluate.
Yes, sir, sure. I will work on it.
And another thing is, coming to your methodology, actually I would like to see at a high data flow diagrams, how different modules are communicating with each other. Okay, so here I know that you written an activity diagram. It is explaining what is the process flow, but it is not explaining high level data flow diagrams. So what I mean by that is, what are the modules which are there in your project, and what are the technologies which are there, how these technologies are coming with each other, and how the data is flowing from one module to another module, You simply the user has to enter. For example, let us say you want to create a task, The user has, you are explaining, what app will do, how to work with the app, but internal workings, as a technical person, it is your documentation is something looking like a user manual. You understand my point?
Yes, sir. Yes, sir.
That activity diagram and your methodology, it's moreover looking like something like a manual that we are going to give for the user, so that by using that manual you can use that app. But when we are talking in the when we put the methodology in the documentation, we would like to see how the different technologies or modules are communicating with each other, how we are interfacing them with each other. So what I am precisely saying is, the moment a student enters a subject, so what module comes into the picture, who is creating a folder, and which module is taking over the NLP processing, who is performing the mining, who is performing the internet search, and how we are selecting the results, and how okay, I know, we are unable to achieve that particular objective, but at least you tried out, so you need to explain at least in the methodology, what are the, otherwise, you need to drop that objective altogether, so that you never mentioned that objective, so I never mentioned this question.
Okay, sir.
Yeah. Okay, I go through your final document, if at all anything, I will comment on the report, that I am going to submit to our coordinator, sir. Is that okay for you?
Yes, sir.
Yes, thank you.
Thank you, sir.
Anwar, sir, I think.
Okay. All right. Thank you, Mr. Satya.
Yes, sir.
Right. Okay. So, Sahara, please take note all the advices. So next we move to the last presenter, Sivaranjini. Are you ready, Sivaranjini?
Yes, sir.
All right. Thank you.
Morning to everyone. Myself, Sivaranjini Sivaraman from BCS. Today I'm going to explain my FYP titled Design and Modeling a Smart Wearable Pet Tracker Associated with GPS Tracker. My supervisor is Mr. Satydevu and Dr. Ahmad Anwar Zainuddin. So as a key accomplishment of my FIP paper, my paper got accepted in the International Conference on Green Energy, Computing and Sustainable Technology in collaboration with the IEE Malaysia, COSMOC and BTS Joint Chapter, which will be held in 7 to 9 July 2021. So the table of this content of this slide will be abstract, introduction, literature review, research methodology, result, conclusion, references, and appendix. So first of all, as an abstract, so like many individuals who live by themselves with friends or family truly feel lonely and depressed when they're unable to join their family outdoor sports and this we urge people to look for some suitable indoor activities to relieve unwanted loneliness and depressions. Having a pet is one of the finest pastimes since like it may generate a lovely and happy ambience. And how horrible it would be like if someday our pet get lost and we couldn't find it. So this pet tracker app will help the owner to track their lost pet. A GPS sensor is used to communicate the position of the pet will be tracked by the GPS tracker to a mobile application, and this technique is recommended for pet owners who are concerned about losing their dogs. And there are also some systems available in Malaysia, but they are more concentrated on vehicles and kids. And there are also some pet tracking system available in overseas, but then it will be like so expensive for Malaysian pet owners to buy it if the application has some repairs to be done. So they have to send it to the overseas to repair it again, and thus will cost a lot for the pet owners. So a GPS sensor will be attached to the pet's collar, and the owner will be can get to track their pet using the pet tracker smartphone application, and the pet circuit sensor will communicate with the pet's location to the mobile application. So as the problem statement, pet missing scenario in Malaysia is increasing, and according to a survey done by the Department of Pet Services in Putrajaya in 2019, the percentage of roaming pets in Malaysia is 81.6%, and this might also include the number of lost pets and like who couldn't able to find by the owners, and thus make the owners to feel bad. And concurrently, the pet owner like waste a lot of time and resources by looking for their lost pet. And some of them willing to pay money for anyone who can find their pet, and this makes the pet owner life so hard. So, as a research objectives, this project's main objective is to create a mobile application that helps pet owner to track their lost pet without spending a lot of energy, time, and money. Moreover, to assure that pet owners that this pet tracking mobile application will make their life easier and also help reducing the number of stray pets in the street. And the real objective of this project is to design a communication architecture with the GPS tracker and mobile application. Secondly, to create a mobile application and GPS tracker to transmit and receive info about the location data. And thirdly, to analyze the existing feature of the pet tracking system to see if they are suitable for Malaysian pet owners. As an hypothesis, firstly, to reduce the amount of missing pets and reduce the amount of stray pets in the environment. Secondly, to provide the pet owner the pet tracking application to track their lost pet by using the GPS to improve the accuracy. And thirdly, to notify the owner about their pet monthly checkup date and vaccination date. And this will be an extra feature of the Petro Track application. So this mobile application can be made. Secondly, what are the data generated from the GPS tracker and mobile application? And thirdly, what is the strength of GPS tracker and AI in the mobile application? As a literature review, so the literature review will be based on the GPS and the mobile application and smart wearables. So I have presented here 5 papers from all the 12 papers I have researched for my FIP. Today I'll be explaining one paper that mostly helped with me to do my FIP project, and it is about tracking and behavior monitoring application, and the paper was written by Lemonson, Valentin and Winters in back 2015, and the data exchanged by the application will be like the postures of the pet, like sitting, standing, lying down, sleeping, eating patterns, walking, climbing stairs, and sending vibrational audio signals. And the wearable of this application will be like a wireless accelerometer, wireless gyroscope, motion sensor, GPS sensor, and RFID tags. The non-wearables would be like smartphone, mobile network, and social network. So I chose this paper because this paper explains and discusses more about tracking and behavior monitoring, which is something related to my FIP paper. And this paper is also included about how a GPS will be included in a secure and how it can send the location data to an application. The research methodology. So I choose Agile as my SGLC because this was the best shoot for my project. So the Agile has 6 phases, which plan, design, develop, test, and release feedback. In the planning phase, the planning of the project is discussed and the requirement of system is defined, and also planning the requirement of application is like most important part, which will lead to a successful app creation. And I I also like planned about the project in this planning phase, where like I included and written down all the requirement the app should have. Secondly, in the design, so this is where the mobile application design was built, and to generate a good design, the input of the project must be understood and the design must stay unique from other applications, and it also need to be like simple so that the user can understand the user interface easily. And in the second phase, and also this prototype was built based on the Android devices, and the Android Studio was application that was used to develop the vector tracking application, and the language used was Kotlin. And Android IDE is Arduino IDE is used to code the Arduino code, which will be connecting the sensor circuit to the Wi-Fi module and will be transmitting the location data to the 5-way system. And during the development, the most significant module that is crucial to the system, as well as module that has been highest demand from the pet owners, will be prioritized. For example, like detecting the pet's current location. And in the testing phase, the Petto tracker application was presented for test, and it was also tested in a way of user interface testing, unit testing, and like with unit testing, including the testing of each module functioning, and user testing was involving the testing for the existence of the fault in system user interface. And finally, the module has been thoroughly tested and found to be error-free, and then the user accepted test is performed to confirm the system can satisfy the clients and meet the specification of the clients. So in the release phase, the application was defined and then was released to the use by some of the people, and then feedback was gathered from the people, like from the some people who I released the app to. And I conducted a survey to get the feedback, and the survey was explained thoroughly in the report. And the survey was had 35 answers. 35 people answered my survey, and there was 2 categories divided in the survey. Like first category was asking about the demographic background, and the second category was about the importance of the application and the hardware and software requirements. So the hardware used was VMOS D1 R1 GPS Neo 06 module, 5V battery, DC jack connector. GPS Neo 06 is a circuit used to a component used to track the current location, and the 5V battery was used to give power supply to the circuit created, and the DC jack connector was used to connect the battery to the circuit, and some wires was used to connect all this part together, and pet collar was used to attach the circuit to the pet collar. And the software used was Firebase, Arduino IDE, and Android Studio. The Firebase was used to save all the location data sent by the GPS tracker, and also to save all this information presented and saved by the user in the application, and was also to connect the GPS to the Wi-Fi and also to the Firebase system. And Android Studio was used to create the application. So as a result, this is the circuit, and the circuit was built with the VMOS D1 R1 board, and GPS Neo 06 is a GPS receiver, and some wires were used to connect these parts together. And Firebase, it contains all the data saved in the application by the user, and the location data is transmitted by the GPS circuit. And as a conclusion, the communication architecture between the GPS tracker and mobile application is being designed, and also the tracker circuit hybrid works because it sends the location data to the Petto tracker application. Hence, my first objective was achieved. Secondly, create a mobile application and a GPS sensor that would transmit and receive data. And the agile model was chosen as the most appropriate technique for dealing with this project, and as the needed function were executed. So created a GPS sensor that will like sending the location data to mobile application I created, which was spectral tracker application. Hence, the second objective was also achieved. And thirdly, examining the existing pet tracker system features to see if they meet the demands of the Malaysian pet owners. And a survey was also conducted to assess the parents' perception of the system and their needs in the relation to it. So like I got to examine like the existing pet tracking system through my through my literature review part, and also I conducted a survey to see if the people are aware and was interested in the system or not. So that's all from my side. Thank you.
Demo of my project. So this is how the circuit will look like. So once it get connected to the network, it will be updating its location data constantly to the fireways. So example, I placed the circuit on my dock, and once it started move, the location will be keep updating in the Firebase and also in the application. So this is the application, and in order to log in we have to enter our email and password. So once we log in, it will show the main menu, and once we click on the pet, it will show the pet details that already inserted, and also if a health record shows all the health records of the pet. And for the tracker, it will be showing the location of the pet and our location. If it doesn't show, we have to refresh, and it will be getting the location data from the Firebase and show in this application. And the location will be opening the Google map, and to log in we have to press logout, and then to sign up a new account we have to enter the email and then upload a profile picture. So once we upload it, we have to sign up. So if it's already user existed, if we couldn't log in into sign up the account, so we have to change the email address. So once we included a new email address, it will allow us to sign up. So once we file uploaded, it will be into main menu where we have to enter the pet details and like name, ID, pet's age, and then the gender of the pet and the type of pet, either a dog or cat. And then like for we have to also upload a pet's picture and save. And then we have to health like input all the health records of the pet. So if like we have to refresh, and then like health record will be opening, and we have to input all. Also can set a vaccination date, which it will be giving us notification. This is the demonstration in the Android Studio. So the total number of modules I used was 5, and once we run the code, it will be showing a mobile view of the application interface. So it shows the same thing, like it will be showing the login and then the main menu, and then like each of the function as I was already explained earlier. So this is how the testing, the interface testing was done. So it will be showing every modules that are written as a code. So that's it for the demonstration.
For FYP2.
Okay, thank you, Sibaranjini. So now I would like to call Mr. Shamil for the Q&A.
Okay, Shivaranjani, am I audible to you?
Yes.
Okay, fine. So whatever you have done, it looks good. So I believe you have learned a lot of things in this practice, and congratulations that you are going for a conference presentation. I have some comments for you. So if you can clarify my doubts or confusion, that is good. Otherwise, you can discuss with your supervisors and if required, make some corrections or amendments. First of all, what I read from your topic name, it reads as just 1 minute. It reads as design and modeling a smart web wearable pet tracker associated with GPS. So I believe the whole project is about pet tracker only, but in your project you have something with respect to food, something with respect to health system as well. So I don't understand what is the reason for that, as well as that is not included in your objective at all. So either it is a deviation from your task, or it is not included in your objective. You can
So it's
yes.
extra feature I added to the application. Like I just added it by myself for the pet health record.
Okay, that is a good feature to add, but in that case you can rename your entire system to be a pet care, not pet tracker, because pet care means it is tracking, it is health information, food information, everything. It's a pet care system. So you can think about it. That is one thing. Second, I believe you have completed your work and you gave a demo of, I believe, your own pet.
Yes, sir.
Yeah. So in that case, you have done it. So whatever you could do, you have done. In the future scope of your report, I couldn't see anything which is meaningful. It just gives a whole summary, but no futuristic point of view. So what beyond what you have done? So what I can see right now, the circuit is quite a big size, which has to be put in a carry bag, and then you have I believe you have a battery or something which is there. You can think of the reducing the size or increasing some modules, but that is not I could see in the future scope also.
The thing is, like, as I in this MC, I could only get this circuit. I couldn't go outside and look for it, so I could only buy in online. So this is the only size I could get for now. So that's the reason.
I'm not saying your current thing is wrong. I'm saying in the future work that you wrote after conclusion, you could have added some more thing, because in the future scope, there's nothing mentioned over there.
Oh, okay, sir.
Yeah. And the third thing, which is something confusing to me, your objective, you have 3 objectives. The objective 1 and 2 is more about your architecture for the communication and the application development. The third objective says analyzing the existing features. I believe that is anyways a part of your literature. So what extra you are doing as an objective over there, that I got confused.
Thing is, as there's no like an application in Malaysia that focuses on tracking any pets. So I wanted to do a research like if the Malaysian pet owner is interested or not. So like also like wanted to like research if what kind of scope they are looking for in the application. So that's the reason I stated that as a objective.
Yeah. Okay, I understand. It is definitely anybody like you or any student who is doing project. They have to do a lot of background understanding, research, paper analysis. That is your task. That is a task in literature survey and in your regular understanding of the project. But that is an objective for you, and that is number 3. Even if you put as an objective, it should be coming the number 1 objective, because you are doing this first and then you are doing some development. So either it should not be there, or if it is there, should be the first priority. You can think about it. Okay, and the circuit that is there, I believe it is entirely bought, not built, right?
Yes, sir.
Okay, fine. Fine. Then you have something called as a feedback or survey you did from some audience. I couldn't realize the importance of that, because you have given nearly 6 or 5 pages of the feedback report, whereas it is a very minimal thing. I believe you could have summarized in 1 table or 1 graph, or maybe 1 page, half page of document. You have given a lot of emphasis for the feedback. After that, if you have got the feedback already, which means you have got all the information, then how come it is agile process? Because you have all the clarity in advance. If you know everything about the requirements from the customer, from the literature survey, then why it is required to go for agile model? You can think about that also. Okay. So that is all the comments from my side. At the end, the research methodology, I couldn't see much about the communication architecture and the design of the GPS tracker, which is your major objective. I couldn't see that as an important part of your research methodology. It says about the HDLC, the feedback, the UML diagrams, but not exactly the GPS tracking module. You can see to that also. Okay.
Okay, sir.
Yeah, that is all from my side. Good work.
Thank you, sir.
Okay, thank you very much. All right, Sivarajani, please take note all the devices. Okay, so I think we have come to the end of our session. Right. So I would like to say thank you to all the examiners and also to all the presenters for today for your good work for this semester. And for your information, all the correction, okay, all the correction, I will announce the date when you can submit the final.
Dr. Anwar, we can't hear you.
Can you hear me?
No. Or is it only me?
It's not clear. Yes, not clear.
Not clear.
Yeah, not clear.
Okay, wait. Okay, can you hear?
Yes.
All right. Okay, I repeat again. So thank you to all the examiners, okay, for evaluating this FIP2. And also thank you to all the students and for your information regarding to your correction for your FIP2. So I will announce the final date, okay, when you can submit all the correction for the finalized version. Okay, so I think that's all, and thank you very much, and bye bye.
Thank you, sir.